All right. So we are going to do an example of the fundamental theorem of calculus. Can someone remind me what the fundamental theorem of calculus is?
The fundamental thing, which is important. It's if a definite integral on a definite integral on the interval a to b is the same thing as the antiderivative evaluated from a to b, which means antiderivative at b minus antiderivative at a.
Yep.
And also you can forget about plus c.
In this specific case, you can forget about plus
C. So we are immune to killing hedgehogs right
now. No killing hedgehogs for today. Yes. So fundamental theorem of calculus. I believe at the time I made the video, I made it based off of a friend's notes, and she called it like the first part and the second part. But most people call this the first fundamental theorem of calculus. Most people call this that. And then the next part that we're going to learn, they don't call it part 1 or part 2, they call it the second fundamental theorem of calculus. So from here on, ignore what the video says about what we're calling it. I'm telling you now that we're calling it this. I'm not going to remake the video just because I called it the wrong thing. Okay? That's just a lot. They will have this video. There is no one absent. But they will have this video to correct them. Okay? So we're going to call this the first fundamental theorem of calculus is this. That when you deal with a definite integral means that it's defined on the interval. Then you just find the antiderivative, and you plug in the upper bound, and then you subtract off the antiderivative with the lower bound plugged in. Easy peasy. All right, so I wanted to do an example of a piecewise function with you because that's just a little bit funkier. Or not piecewise, sorry, absolute value function. So we're going to say negative 3 to 7 of the absolute value of x minus 1 dx. Okay, so we are not going to think of this as an absolute value because we never think of absolute value functions as absolute value when we deal with them in calculus. What do we always do? Piecewise, which is why I misspoke a second ago. So instead of calling it the absolute value of x minus 1, we are going to rewrite it as a piecewise function where we have the negative version and we have the positive version. And I should say if
x is less than 1.
If x is less than 1, if x is greater than 1. And then one of these has to have an equal to because in that perfect V-shaped graph, there's not a hole at the vertex. So I'm just going to choose to put it right there. I'm not too worried about it.
Wait. Actually,
you could put it at the other one. Yeah, it doesn't matter. You have to do it on one of them because it is a continuous function.
Would you do it at both?
No. Because then...
Yeah.
All right. So here's what we have. We're going to take... This is what we talked about. We're going to take this integral. We're going to write it. We're going to split it apart. So we're going to say negative 3 to 1. Which side of the piecewise function is that?
The one where it's less than 1?
Yeah, the left side, right? So I'm going to say of negative x plus 1, I went ahead and I just simplified it a little bit, negative x plus 1 dx plus, and then what should I write for the other one?
1 to 7.
1 to 7. And then what should go in my parentheses?
X minus 1.
Okay. How did I know to split it at 1?
Because that's where they split.
Yeah, that's where it splits. That's when you look at the V, you've got one line segment, and then you've got the other line segment. So that's what we're doing is we're just splitting it where it was already split on its own. Okay, so it's not always going to be at 1. It could be wherever the vertex happens to be that makes it switch. Okay? All right, so if I take the antiderivative for this first part, what do I get? I can show my work if I need to. So I've got negative x. It's a 1. It's to the 1 already. So I add 1 to the exponent, and then I divide by 2, right? So negative 1/2 x squared plus x. And this is going to be evaluated at Okay. And then what about the other one?
1/2 x minus x. X squared.
Okay, 1/2 x squared minus x, evaluated from 1 to 7. Okay. So I've got negative 1/2 times 1 squared plus 1 minus negative 1/2 times negative 3 squared plus negative 3. And that's like a whole big chunk there. That's the first one. So what am I doing right now?
Evaluating the antiderivative of -3
Mm-hmm. Yeah, so I'm just plugging the numbers in. Now, I will say that on the AP exam, when students get problems like this wrong, I'd say it's because they didn't show enough work. They just started doing things in their head, and then the answer choice wasn't there, and then because they didn't write down the work, they couldn't go back and fix it, and then things got all like stressed out and anxious because it was a test. You know what I'm saying? So yes, by all means, do some of this in your head, but also recognize your own weaknesses, where if you do too much in your head at the start, then you run the risk of just confusing yourself or missing something and then not being able to see it. So I've got negative 1/2 plus 1, which is 1/2. And then I've got negative 1/2 times positive 9. I'm going to go ahead and show more work on this one. So it's negative 9/2 plus negative 3, which is negative 6/2. So I have positive 1/2 minus
negative 15 halves.
Okay, and so what does that give me?
16 halves or 8.
16 halves, which is 8. Okay, and then over here I've got 1/2 times 7 squared, so that's 49 halves. I'm so popular, you guys. And then 7 would be 14 halves. Okay, and then we've got 1/2 minus 1, so negative 1/2 there. 49 minus 14. 35 halves. 35 halves minus, nope, minus plus 1/2.
36 halves.
So this plus 36 halves is 8 plus 18 is
27.
Okay. And if we wanted to use our calculator to check our work for today, what would I type? That's not that bad, because you can type the absolute value. So we're going to do math 9, and we've got from negative 3 to 1. Oh, just kidding. I needed the up arrow. Negative 3 to 1 of absolute value x minus 1. And I'm not your calculator. Use your own. Oh, no, it should have been negative 3 to 7. I typoed. This is don't trust me. Do it yourself. I'm not your calculator. Your calculator is your calculator.
I mean, you can do negative 3 to 1 and then add from 1 to 7.
I could. My negative 3 to 1 was a typo. I didn't mean to do that. Yeah. My calculator is struggling to say 26. Or you could type it in like we did separately. Oh, dang it. Don't immediately press enter because you'll get frustrated like me. So there's the 1 plus 1 to 7 x minus 1.
That's a 1. Never mind.
Or it's exactly 26 then. So
Science.
fancy. All right.
Why isn't it exactly 1 up there?
I'd have to look into like what the process, like how your calculator works. Yeah. I always just say your calculator's struggling to do the right thing. Having a hard time. All right.
But it went out, yeah.
It did. All right. We're adding to your notes again. Ready? This is kind of like a warm-up problem, but we're going to do it together.
Is this our last adding to the notes thing?
Yeah. Okay. We're going to find f of x, and here is what I'm giving you. I am telling you that the second derivative is 2 minus 12x, and I'm going to tell you that f of 0 is 9, and f of 2 is 15. Okay. What should we do?
First, we have the derivative to get the first one prime unit thing.
2x minus 6x squared.
Plus c.
Okay.
Let's call this c1.
You can't solve for the c.
Yeah.
And you can't solve for the c. Why?
Because you
Oh, yeah,
don't
we don't
have
have-
anything
yeah, no.
there.
Yeah,
So
they
just
they didn't tell us any f prime of anything was anything.
but they did
So we
give us
couldn't solve for
two
C.
different equations.
But they did. Okay, so we have two options. We can do C1 and C2, or we can do C and D. I've seen it done both ways. C and D? Okay. Marvelous. All right. And then f of x is
X squared minus 2x cubed plus cx plus d.
minus, right?
Yeah, right.
2x cubed plus
I wrote minus, but I said
cx plus d. Okay.
So d equals 9.
Okay.
Does it have to be capital D?
Yeah,
Practically, yes, because it's a constant. I mean, right?
Thank you, Miss Rice. All right, so what do we do now?
Plug in 2.
Plug in 2. I guess I could just do that. I'm so used to showing all my work for the lower classes, but you guys don't need all that work. Okay. Plus 2c plus 9. And what does it equal on the other side?
I don't need that negative.
Yeah, you're reversing that.
Oh, there's a plus 9. Yeah, that's.
I got C.
Do you guys like how it's out of order? It like makes me feel a little bit of like pain. I'm like not enjoying that. Like, ugh. It makes me feel a little twitchy.
Your soul. Yeah, well, I mean, I just flipped the sign back to
All right, here's the next one. F double prime of x is 2 plus cos x trig, our favorite. F of 0 is negative 1. F of pi halves is 0. And I'm going to let you guys do this one on your own. Ooh.
Trig derivatives aren't so bad. It's just the
especially
actual
when you have
derivatives.
It's the evaluating using a unit circle.
It's just short and zero. Sometimes.
Alright, you ready to get my signal?
What day is today? The 12th?
Tuesday. The week after next week.
But Miss Rice,
Mm-hmm.
I will not be here I'll be here this Friday, but the Friday after that I
I will definitely forget by then.
Yeah.
So just check the website. Regardless.
I'll make sure it's not a quiz or a test day, and if it is, I'll take that Thursday.
Oh, ooh.
Chris, what'd you do first?
Did you guys get plus sign or minus sign? Plus sign. Good. This is when they start to get confusing because now we're doing derivatives and antiderivatives.
Seriously, that circle model is super helpful.
Right.
So D and C.
Yeah.
Spoilers. Oh, D? Oh, yeah.
No, decent.
Yeah.
No, because cosine, cosine of 0 is negative 1. Because, yeah.
So you got C of x equals x squared minus cosine plus C of x plus 1.
Big brain is here.
I thought that was, it looked like a parenthesis, a 1 and then C first.
No.
Now I can tell it's
I got an answer.
I wonder if I got the same answer I got last year. I did. That's fun.
What answer? Cool.
I was correct.
Oh, that's not a C anymore. Okay. Wasn't that fun? Didn't you guys enjoy that?
Yeah.
What a wonderful question. I like the trig one. I feel like the trig one makes me extra cool because of all the pies in there. It's like, whew, that was hard and I made it, you know? Nobody? All right. So today's assignment is a little bit on the shorter side, which is fair because tomorrow's assignment's a little bit on the longer side and that balances out, right? Ooh, okay, so we're going to work on today's assignment. We have video notes for tonight. If you finish today's assignment early, what should you do?
cheat sheet or problem set.
Cheat sheet, problem set.
Cheat sheet it for me because I did my problem set.
Ooh.
Whoa.
What did you ask?
Good job, Tristan.
The notes for tonight are... The notes for tonight, nope, that's not it, are 20 minutes. 21 minutes.
Let's go down.
You didn't say please, of course she's not going to do it.
It is a Star Wars meme.
Oh, you haven't done it yet. Sorry. You haven't learned it yet.
Oh, we haven't done it.